Welcome to Alaska Earthquake Science Facts. I'm Carl Tate. Prior to the 1969 Milrow nuclear test on Amchitka Island, ocean bottom seismometers, OBS, were employed to record the shot and any other events. It was the first OBS deployment for regional monitoring. Seismology on Earth is a limiting endeavor if seismometers cannot be placed in the ocean. We're trying to record activity and understand how waves propagate through the subsurface structure of the Earth. It's going to be very challenging if we're not able to cover so much of the Earth that is covered by water. And people have been thinking about this for quite a while. This is a 1938 paper entitled Deep Sea Measurements Without Wires or Cables. Right there telling you kind of what the problem was at the time and what they hoped to achieve. There's been long need for putting seismographs on the ocean floor and recording activity. But how this was achieved was a steel cable connecting a ship down to these instruments. And as it shows here, 3 miles of water. That's a logistically challenging thing. Not only that, but this steel cable is going to put all kinds of noise source that you don't want into your recording system. So these authors in 1938 said, can we devise some technology that would allow for recording remotely and with some oil-filled balloon, given a signal, can launch our data up to the surface for retrieval. Fast forward a few decades, and this was being realized, the telemetering ocean bottom seismograph, 1961. So there were individual stations here and there testing this technology. 1965, ocean bottom seismic observatories. And this paper is published the same year as the first nuclear test at Amchitka, long shot. And a few years later, we'll see that these ocean bottom seismometers were deployed in the same area. So here's the region of interest, Amchitka Island here in the Western Aleutians. And this shows a map from a report that shows stations that are clearly not on islands. So here's Amchitka Island, here's some islands, and these dots are recorders on the ocean floor. And so that's a whole new technology in terms of surrounding these. This isn't just one isolated observatory. This is trying to achieve regional monitoring in the same way that they wanted to put stations on nearby islands. The red circles are the ones that I'm able to match up with some figures that appear in journal publications. So keep your eye on these 4 red ones. Here they are in a 1972 paper by Engdahl and others. We don't see the full extent, and it doesn't look like they all operated as successfully as they wanted, but the technology was out there, and they were recording events associated with these natural activity and also the explosions. The seafloor poses logistical challenges for deployment, recording, such as accurate timing and retrieval. The environment also produces lots of noise, most of which is undesirable. Seafloor seismology remains a challenging and active area of research. And in 2018 and 19, Alaska hosted a large experiment of on-land and offshore seismometers. This shows the team effort and the abstract, the Alaska Amphibious Community Seismic Experiment. Shoreline crossing of passive and active source seismic experiment along a 700-kilometer long section of the Aleutian subduction zone from Kodiak Island and the Alaska Peninsula. The experiment featured 105 broadband seismometers, 30 were onshore, 75 were offshore. This shows a map of that experiment, and the real significance here is just all these dots that are offshore. New technology. Some of these are in the deep ocean. So here's the trench right here. You can see the deep section, and then this would be the continental shelf. So different technology needed for these different sections, but providing coverage of an important region of the subduction zone that previously had none. And this shows a photograph taken from the Sikuliak, the the research vessel used to deploy the ocean bottom seismometers that appeared in a AGU paper in 2019, sort of a picturesque view of science on the ocean. Takeaway topics: seismometers can be installed on the seafloor to improve monitoring of tectonic activity in oceanic and island regions. They can also be used to image the subsurface earth structure in oceanic regions. Thank you for watching. Please stick around for supplemental material.